All right, so let's take a look at section 11.1, okay, slope of a line. Anybody know what, before I put up some examples, what slope measures? You could think of it as a line, or you could think of a situation in real life that slope.
The angle of the line.
Yeah. Okay. So an angle. What's it measuring? It's not measuring in quite the angle, but it's measuring how
steep it is.
Steep. Okay. Exactly. It measures the steepness. Okay. So there's all kinds of situations in real life where you measure steepness. Okay. Stairs. Okay. Stairs have a steepness to them, or a slope. Okay? And when you build stairs, there's certain codes that you have to make sure your stairs aren't too steep, or especially a wheelchair ramp. Okay? There's certain codes that say, this is how steep you can make your wheelchair ramp. It can't be any steeper than this. Okay?
Guys, none of this, believe me, when the stuff, the first thing that's on the guided notes, you'll know. All right, I'm going to take over from Mr. Hager when that comes up. Don't worry about it. We're just giving you guys a general idea of where you can use slope in real life. Okay? Again, this is a good, slope is actually one of them real world applications. It's not like, you know, when you're doing like we did like direct variation and stuff last week. This is real world stuff. Like you can see it a lot in your shops and stuff like that.
So any kind of hill, especially if you're driving, okay, there's a lot of times you see a sign out on the highway, it'll say like 8% grade or 6% grade. Anybody ever see one of those signs on the highway? What that's telling, it's not really for cars as much, it's more for bigger trucks. It's telling them how steep the road is coming up. All right, so if they need to shift or try to slow down a little bit to get ready because it's a really big truck, they can do that. All right, so it's measuring the slope for them. All right, so slope, the way we define it is it's a fraction. Okay, it's a ratio. Okay, and somebody earlier, I think, said it. Anybody know what rise over run? Yep.
So guys, on your thing right there, see that big black line that's in the middle? All right. On the top of that black line, what do you think you want to write?
Rise.
Rise. Again, don't write over. Is it on here, Mr. Hager? That should be on here, right? Oh, not yet. Okay. So you're going to write, on the top part, write rise. R-I-S-E. Right on the top of that black line. Then on the bottom of the black line, you're going to write run. Rise over run. Now, notice, guys, that there's some different, like, parentheses and equal signs. Don't worry about that yet. We're going to get to that. As long as you have rise over run, you're on the right track.
So here's kind of an example of a hill, maybe looking at it, or a ramp from the side. Okay, and it tells you the rise. Okay, if this hill is 20 feet and the run is 50 feet. Okay, so somehow you have to remember rise is vertical. Okay, think of if you let something go, what does it do? It rises, right? Rises up and down. That's vertical. Run, think about when you walk or you run back and forth, that's horizontal, right? When you're on the ground and you run, that's horizontal. So run, horizontal, rise, vertical. Okay? So what would be the slope of this hill? You don't have to reduce anything yet if it can be. Just tell me what number would go on the top, what number on the bottom. 20, yeah, 20 over 50. Okay, so the slope is rise over run. Now, can 20 over 50 be reduced? Yeah, 10 goes into 20 twice and 10 goes into 55 times. So if you can reduce a slope, we usually do.
Yeah, we're going to get to that a little bit later.
One thing we never really do, though, is write it as a decimal. Okay, you're not going to take your calculator and write your slope as 0.4. We don't do that. Always leave it as a fraction.
So guys, Mr. Hager says we don't want to put it as a decimal. Why? Anybody think they might know why? Why we don't want to put it as a decimal? Go ahead, Isaiah.
It's harder to work with.
What do you mean harder to work with? What are we going to have to do with this slope at some point? Probably tomorrow.
Put it on a graph.
Exactly. It's really, like Isaiah just said, it's tough to graph. I mean, you could graph a decimal, but it's tough. But if I'm getting a number on the top, a number on the bottom, I know exactly where to go in my graph, right? That's the reason why Mr. Hager and I don't want it as a decimal, okay?
Okay, so what that slope of 2/5 really means is for every 2 feet you go up, 2 feet of vertical, you have 5 feet of run, or 5 feet of horizontal. Okay? That's exactly, is that the same thing as saying if I go up 20 and over 50?
Yeah.
Or up 2 and over 5? It's the same thing, it's just a larger or smaller scale. Okay? But it's the same idea. Okay, so what we're going to start out with is we're going to find some slopes between 2 coordinates in a plane. Okay, we'll just graph 2 coordinates and we'll find the slope. Now, when they give us a coordinate plane, that's kind of easy. We can just count between the points. How many did we go up? How many did we go over? Okay, if we don't have a grid, we'll talk about a formula we can use after. Okay, but we already said that. Okay, again, so if you don't have it, make sure you write that down. Slope is rise over run. And we'll look at how we find the 2 points, slope of 2
What about
points.
the other 2 things, the equals?
Did that make it on there?
I think that might be coming up.
Okay.
Yeah.
So guys, this is exactly what it looks like on your notes, right? Looks like something like this, okay? On the top, we put what? Rise over run. Now, if your top number, so here I'm going to write positive. Below it, I'm going to write negative. So if I have a number here that's positive, or if I have a number here that's negative, we're going to talk about that right now. All right? So anybody want to take a guess? If the number on the top is positive and it's the rise, what direction do I want to go? Up, right? So all I'm going to do, you can write up if you want, or just put an arrow pointing up. All right? So if the rise, the top number is positive, I want to go up. And obviously, Justin, if the top number is negative, what direction do I want to go? Down. Perfect. I know sometimes you guys forget. And again, when we get to the stuff tomorrow, where we actually use the slope-intercept formula, you're going to need to know this. We're going to get a point, and from that point, based on our slope, we're going to have to know where to go. All right? Then we got the run. Same 2 words I'm going to write. Positive, negative. Now, for my run, right? My run. If my run is positive, I'm going to go to the right. Good, Kayla. I'm going to go to the right. That's not a great arrow, but go to the negative, and go to the left. Perfect. All right, so that's my rise and run. And guys, this, especially for this, and actually moving forward, you're gonna need. And how many people? Is this the first time some people have ever seen this? Be honest. Is this the first time people have ever seen it? There's a few of you, but most of you guys have seen this before. It's not anything really new. All right. And like I said, when we get into the stuff like tomorrow, and even the stuff later in this chapter, this is the key. You need to know, we're going to give you a point, and based on that point, whatever the slope is, you're going to need to know where you have to go. All right? It's not that bad. It's not painful. All right? So rise over run. And again, tonight, on your homework, don't just tuck this thing away. Keep it out. Again, we take notes for a reason. Not to say, hey, we've tried to shorten them as much as possible, guys. But again, we want them to be able to work for you. Don't just say, I can't do it, and shove these things inside a book or something. Keep them out there for you to refer to doing your homework.
All right, so this is the step we were just at before we had to fix the one we had open. So we said before, the rise is your vertical. Okay, it's the change between the 2 points. Okay, so if we give you 2 points on a graph, the vertical distance between them, that's your rise. Okay, your run, that's the horizontal. Okay, we said this a couple times now. That's the change horizontally. If you've got 2 points, how far apart are they horizontally? Okay, lines can have different kinds of slopes. Okay, there's really 4 basic types we're going to look at. Positive slope, negative slope, one that's horizontal and one that's vertical.
Okay, want me to
Right, so a positive slope, okay, what does that look like? It looks just like that. If a line slants upward, okay, if it slants upward as you go to the right, that's a positive slope.
All right, so guys, in your little box there, slant of a line. Your first line, in that box right below it, all right, you want to draw a line that looks just like that. No, right there, see where it says slant of line in the box? In the,
Oh, yeah. You're blind.
right here, in that first box, right below slant of line. Draw one that looks just like this. Exactly like that one.
Exactly.
Well, as close as you can.
Yes, exactly.
Exactly, yeah.
And we would rate
All right, and then next to it, right, on the top of that next column, what does it say? Somebody tell me by raising their hand. Marcus.
It says it's positive
No,
slope.
no, 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 no. What is it actually on your guided notes? The next
Given
column, what's the
slant
heading?
slope is,
Yeah, given the slant, given slant, the slope is what? So if you have a line like that, what kind of slope are you gonna have?
positive.
Positive. So in that box, you're gonna write positive. 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 And some guys, yeah.
I did this earlier.
Okay.
Everybody get that?
Yeah.
So if it slants up as you go to the right, that's a positive. What other kind of slope do you think we have?
Negative.
Yep, you get a negative. So if a line slants downward, okay, as you go to the right, fill that in your box as well. Okay, if it slants downward, that's a negative slope.
And sometimes, guys, we might ask you to based on, might ask you to give you 2 points, graph them, and say based on the slant that you have, what kind of slope. We may ask you to do that, we may not. That's why we're going through this.
Okay, and you got 2 rows left in that table, right? We haven't filled in yet?
Undefined.
0.
We're going to talk about the other 2. I don't think we're going to get to them right this second,
Yeah,
but we will.
they're more towards the end. I know some of you guys already know, but just sit tight till we get there.
Okay, let's look at that. Okay, look at that line. Is it slanting upward or downward?
Upward.
Upward. Okay, that's going upward. So what kind of slope should you have right away? Positive or negative?
Positive.
Positive. So if you get an answer on a test and it's a negative,
Do we draw that?
wouldn't make
Again,
sense with that
guys,
picture.
this is just a review as a class. It's not on the guided notes. We're just looking at it together.
Okay, what does it say your rise is here? 3. What's your run? 2. And your slope is 3/2. Okay, 3 over 2. All right, look at this one. Okay, which way is your line going now?
Negative.
Slanting down, so your slope, right away, I would put down a negative, so you don't forget. This is a negative slope. Okay. Now, look at the rise between the 2 points. The rise is the vertical. 1, 2, 3, 4, 5 units. Okay. We already took care of the down. That's what the negative did. What about the run?
4.
Yeah, 4. Okay, count 1, 2, 3, 4. And again, put that negative down right away so you don't forget it's a negative slope. Any questions on that? Just an example of a positive and negative slope.
If somebody put it as, what if someone put it like this, Mr. Hager? Would you accept this? If we had,
Yep, that's fine.
okay. Again, if you guys can't, if you have a hard time remembering, what direction it slants, if it's positive or negative, just know if I'm going down, I know it's negative. If you're going down, that means it's negative. We need to know that.
So whether or not you put the negative in the top of the fraction, you put it in the bottom of the fraction, or you put it kind of right in the middle like I did, all the same thing. All three of those would be acceptable. So let's try graphing a couple points. This is a good review. Make sure we know how to graph a point. And then we'll draw the line and calculate the slope.
So guys, these two are on the front page of your notes.
Okay, someone tell me, how do you get to the point 2, 3?
You go to 2.
How do I go to 2?
Left
2x. Right, 2x3.
No,
Up, 2. Right.
Okay, first number represents what? The x or the y? Second number? Which one of those is your horizontal?
X.
X. So the 2 is either going to be left or right. It's horizontal.
Right.
Right 2,
Yes.
Positive 3 up.
and then 3 up. Okay, so that's A. What about 7, 6? How do we do that one?
Go to the right.
Right 7,
Up 6.
up 6. Okay, and now draw your line going right through those points. Let's do it the best you can. Now let's get our slope. What's the formula for slope? Rise over run. Okay, what's the rise? Yeah, look at what we've done. We've gone up, go straight up. How many up did you go? 3. So you slope 3 over, and now what's your run? Is it 5? Let's see, we go over 1, 2, 3, 4, 5. Good. And why did I put my slope as a positive? Why didn't I put it as a negative? It's slanting upward. Good. Slanting upward.
and plus I'm going up and right. Those are both positive directions, based on the notes we took earlier.
Okay, let's try that one. 2, 5 and 6, 3. Well, Joe, how do I graph the point 2, 5?
Go to the right for 2.
Right 2. Good. Up 5. Okay, and the point 6, 3. Brian, how do I graph 6, 3?
Go to the right 6. And up 3.
Up 3. Before we even draw our line, can you tell if this is going to be a positive or a negative slope?
Negative.
Negative. Why? So when you describe the slope, we talk about the slant. This is going to slant which way?
To the left.
Was it upward or downward?
Up left.
Down. So we always talk about when we go to the right, does it slant up? Or as you go to the right, does it slant down? Okay, that one slants down.
Now, Justin, how would Mr. Hager figure out the slope of that?
We go straight down 8.
Down how many?
2.
Down 2.
So we would make sure that, how would I show that? Is that a positive 2 or a negative 2?
Negative 2.
Negative, because we're going down.
And then go over 4.
Positive or
Positive
negative?
or negative?
Positive.
Positive, right?
Yeah.
What direction are you going there, Justin?
Right.
To the right. If I'm going to the right, it's positive, right? If I'm going to the left, it's going to be what? Negative. Good. And again, that's, like I said, if you're not sure of like that slant kind of screws you up, like I'm not really sure what direction that's going, again, just know up is positive, down is negative, right is positive, left is negative. You can do it that way too.
Any thoughts on that slope? Negative 2/4.
Could be reduced.
It can be reduced, yep. What can you reduce it to?
Negative 1 is half.
Negative 1/2. Okay. Now, watch what happens when you reduce it. Okay. Pick a point somewhere on that line. Basically, the slope gives you directions on how to get to another point. It says go down 1 and right 2. Down 1, right 2. And you can keep doing that and getting more points on the
So,
line.
Mr. Hager, when we have a negative one, a negative slope like that, always treat the top number as a negative.
That's how I do it, yeah.
Yeah, so what we're showing here, guys, is, because look it, if I treated these both, and we're gonna get to this in a second, but just to show you guys, if I treated these both as negatives, I'd go down 1, then what direction would I go? If it's negative 2? Over 2. I'd be off the line, right? Always treat the top one as a negative, bottom one as positive, right, when you graph.
So in other words, we'll either always go down and right or up and right. But we're always going to go right. Just we're going to decide up or down. Yep, we're always going to go to the right. Okay, example 1C, we're going to skip over that for now. If we have time, we'll come back. All right, so I think we've got a pretty good idea of how you measure the slope as long as you got it on a grid, okay? But sometimes you're not going to have it on a grid, and I'm not going to ask you to put it on a grid. I'm just going to give you 2 coordinates and have you find the slope. Okay, so let's suppose we have 2 points. Okay, and what we're going to do is label these points using X and Y. Here's our first point.
We're on the back side now, guys. Mr. Hager's, we're skipping example 1C.
Okay, let your first coordinate be represented by these 2 variables, x1, y1.
As far as what's on the back, that m equals thing, don't worry about that yet. We're going to get to it. Mr. Hager's just showing you how it works. He's just introducing.
This little number here, this little 1 that's written down a little bit lower, all that means is this is my first x value that I'm going to use and my first y value. For my other point, notice I have the 2's. All this means is it's my second x value that I'm going to use and my second y value. When we do a problem, these are all going to be numbers. The x1, the y1, the x2, and the y2. Okay? It's just my first x and first y, my second x, and my second y. Okay, and I've graphed those 2 coordinates. Okay, we don't know exactly what they are, so we can't put it on a grid, but what we can do is just label it generically like that. Okay, what's our formula for slope again? Slope is rise over run. What's the rise? That's the which way, vertical or horizontal? Rise. Rise is your vertical. Yep. How about your run? Isaiah, which way is the run?
Left to right or right to left.
Yep, that's your horizontal. Okay? So, slope is rise over run. All right? So now, we have to find the rise and the run here. Okay? We don't have numbers. Okay? So we're going to have to find this distance. Think about how could you, if I gave you 2 numbers, and I wanted you to tell me how far apart they are, like 2 and 7. What would you do with 2 and 7 to find out how far apart they are?
Subtract.
You'd subtract them. Exactly. That's exactly what we're going to do here. Let's say this y value was a 9, and this y value down here was a 3. Okay? What's the difference between 9 and 3? 6. So that would tell us that the rise here would be 6. And how'd you get that again? What'd you do with 9 and 3? You subtracted. So that's exactly what we're going to do to find the rise. Okay? What's the bigger number here? y2 or y1, the way we drew it? Which one's higher? y2. Okay. What's the other y value? y1. If you subtract them, that gives you the difference or the rise. Okay? It gives you the rise. All right, so that's my rise. What about my run? How do you think you'd find the distance between here?
Same thing.
Yeah, same thing. So
So it's x2 minus x1.
that's x2 minus x1. Okay? That would be, those would be numbers. You'd subtract them, and that would tell you how far apart they are. Okay? Pretend x1 was 2, and pretend x2 was 5. Okay? Yeah, the distance between 5 and 2 would be 3 units. Okay? So what we're going to do is put those two things together and write our formula for finding the slope. Okay? Rise over run. But you guys tell me, instead of writing rise over run,
MC squared.
how do you calculate the rise? Okay, we just did that. What's the formula to find the rise? So, yeah, subtraction. What do you subtract?
y2, y1, x2.
Why is it we start with y2?
Hold on, we'll get that in a second, Andrew.
Okay. What about, what's your formula? How do you find the run? Good. X2.
So guys,
Minus
is that
x1.
thing on your notes that says M equals? You're gonna see tomorrow, you can see right below M, right? What does it say in that small little font? You can tell me by raising your hand. What does it say? Laura. Represents slope. The letter M, when we're talking about this stuff, represents slope. And then you have that big thick line and the two minus signs. That's what you're gonna write. Y2 minus Y1 over X2 minus X1. That is the formula for slope. Guys, that I put right next to it is an arrow coming off that box, right, Emma? You see it? See the arrow coming off that box? What's it say? Very important. Your homework tonight deals with this. It'll be on the test on Friday. In Algebra 1B, it will show up. In geometry, it will show up. I had kids that when I co-taught geometry for 3 years, did not know the slope formula. It's just not one, this is a really important, this doesn't disappear. All right, this stays with you guys for the rest of math. And some of you guys probably already know it. All right, but again, it shows up in Algebra 1B next year. It'll show up in geometry when you're juniors.
Let me give you guys a hint about how to remember it. Okay, a lot of people, they do all kinds of things. They flip it. Okay, what's on top in this fraction? What letter?
Y.
The y's are on top. Rise. Rise, wise. Okay, it rhymes. The y's, rise. So for the letter that goes on top, remember it's the one that rhymes with rise. The y's. Okay? So that's how you can remember it. Y's are on top because rise. Okay? Everybody got that? Okay? And then on the bottom, those are your x's.
Now, guys, if you wanted to do that, y1 minus y2, you better do it on the bottom too. You can't leave it as x2 minus x1. It's got to be in the same order. The order matters. This does not work. It's got to be.
Just stick to that order. 'cause
Stick
you'll
to
get
that. If you
confused.
want to do y1 minus y2 over x1 minus x2, you can do that. But this is the way that in your book next year, junior year, that's the way it's going to be written. And the order matters, right? You cannot put the x's on top. It doesn't work that way. The y's need to be on the top. This is the way it is.
Yeah, so as Mr. Rice said, there are other ways to do it, but let's stick with this way because I think when people see it other ways, then they start mixing it up. Every year I see it get mixed up. Everybody have the formula?
Yes, I do.
Oh my god.
Get this stuff down to me. All right, so guys, when you have slope, right below your slope formula, right, you have those steps. The first thing you're going to do is you're going to label your coordinates, just like Mr. Hager just showed you guys earlier. x1, y1, x2, y2. All right? As I had something like that, right? 3, my first coordinate is 3, 2. My second coordinate is -3, 1. Ben, if I was going to label these, right, what would the 3 be?
Y.
No. What letter comes first in the alphabet? X or Y? If I'm doing, good answer, good answer. But if I was looking at X and Y, right? If I was comparing those two, which one comes first? X, right? So what is this going to be, Ben? X what? X1. Right here, Ben, what's this going to be?
Y2.
No.
Y1.
Y1. This would be,
X2.
and then,
Y2.
so I know someone in the back had a question of, well, how come there's X and Y, Mr. Roy? This is how you label it. That's what I do so I don't make a mistake. All right? I label them first. So you're going to label your coordinates. Next thing we want to do is plug these in to the slope formula. All right? So I got my line. Just a little more space, right? And it's Y2. So which coordinate, Emma, which one is Y2? 1. After 1 comes what? In the formula, after 1 comes what? What's going to separate the two Y's? Minus sign, good. So Y2 minus Y1, which is, what's the coordinate for Y1, guys? Brian, what's the coordinate for Y1? 2. All right? And then on the bottom, I got X2, which is, -3. And then what comes after that? Minus what? Which is?
What are we doing?
3. All I'm doing there is I took my coordinates and I plugged them into my formula. The one for what?
The second one, you said 3, you said 1, you're gonna have 1.
Y2 is 1, Y1 is 2, then I got my X's. X2, -3, X1 is 3. All right, all I'm doing is taking whatever these values are and plugging them into my formula. I'm just taking numbers and plugging them in. That's all I'm doing. All right? Next step is solve. I'm going to solve it, but there's some stipulations, right? There's some ifs. One of those ifs is, and Mr. Hager showed it to you guys earlier, if the top, so right after if, you're going to want to write this. If the number on the top is bigger than the number on the bottom, you got to ask yourself, do they go in evenly? So when I solve this one, what am I going to get? What's 1 minus 2? Somebody tell me what's 1 minus 2. Raise your hand and tell me. Marcus.
-1.
-1. Then I got -3 minus 3. Austin, what do I get? -3 minus 3.
0.
No.
-6.
-6. Remember, this goes back to like the first week of school, guys.
What?
If both signs,
Oh, wait.
if both, we're adding and subtracting now, right? If both signs are the same, what did we say the rule was? Anybody remember from the beginning of school? Keep the sign and add the numbers together, right? Like when I have 3 and 3 plus 3, they're both positive, right? I keep the sign, I'm going to keep it as positive, it's going to be 6. Same thing here. They're both negative. I keep the sign, which is negative, and add those two numbers together. So let's look at our first if, like I said. If the number on the top is bigger than the number on the bottom, do they go in evenly? Do we have a situation like that there? Dominic, do I have a situation like that there? Do I have a bigger number on the top and a small number on the bottom? No, right? I got 1 and 6, so that doesn't work. But sometimes you might get like 6 and 2. Yes, the number on the top is bigger than the number on the bottom. And then it goes in 3 times. If it's like 6 over 2. Number on the top is bigger. This goes in how many times? 3. There's my answer. But I don't have, again, guys, I don't have a situation like that here. I'm just showing, because some guys make mistakes with this. And again, it doesn't get talked about that often. So if the number on the top is bigger than the one on the bottom, do they go in evenly? If they do, divide. But we don't have that here. Our next if the numbers can be reduced. I think we had a situation like that earlier. The first thing we did, what was it, 20 and 50, right? If the numbers can be reduced, reduce them. Like we had the 20 and 50 earlier, it became what? Anybody remember? We had that 20 over 50, what did we reduce that to? 2 over 5, right? What number did we reduce by? What did we use? 10, right? Again, we don't have a situation like that there. Negative 1 over negative 6 cannot be reduced. All right? We got one more. Now, if the number on top and the numbers on the top and the bottom, they're both negative, your answer becomes positive. By a show of hands, guys, is that true in this case? Do we have negatives on both the top and the bottom? Show me. Do we have numbers on both the top and the bottom? Yes, we do, right? So now your answer becomes positive. So my slope for these two coordinates would be what? My slope for these two coordinates would be what?
A positive.
1 over 6. This will become positive 1 over 6. Again, this is kind of like when we talk about slope, guys, this is kind of like the hidden stuff. Kids I've worked with in the past, this is the stuff that they miss on. And again, sometimes it doesn't get covered in the notes. So I just want to make sure you guys were clear on that. Those are the 3 ifs. All right? So what we're doing, label them. We're going to have some time to practice here. Label them, plug them into your formula, solve. Okay? Make sure you leave in there like the negative sign. You have to put that negative sign. Just because maybe your y1 is negative in the second part, you need to leave it. If you have 2 negatives in a row, what happens? Who can tell me? If I have 2 negatives in a row, what happens? It turns into a positive.
So the reason Mr. Ray is having you label, okay, because if you look at your formula, y2 minus y1 over x2 minus x1. How many different letters, how many different things do you have here that you have to fill in numbers for?
4.
You have 4 things. How many numbers did I give you in this problem? 0, 4, 3, 1. 4 numbers. So our goal is to figure out which number goes where in this formula. That's why he's having you label the coordinates. So you can figure out where's the 3 going to go? Which one of those spots? Where's the 4 going to go? Where's the 1 fit in? Where's the 0 fit in? You've got to find out what number goes in each of those 4 spots. Okay? So labeling it helps us just to organize our thoughts before we start. Okay. So decide right here, the 0. Is this an x or is it a y? Is it your first x or is it your second x?
First.
It's our first x. Okay? Let's look at the 4. Is this an x or a y?
Y.
Is it my first y or is it my second y?
First.
It's my first one. Okay, let's look at the 3. Is it an x or is it a y?
X.
X. My first x or my second x?
Second.
It's my second one. And look at the 1. X or y?
Y.
It's a y. My first one or my second one?
Second one.
Second one.
Please don't talk like that, it's really annoying.
Okay. So now we've got everything labeled. Okay. Now we know where the 4 is going to go in the formula. Okay. Where the 3 is going to go. Where the 1 is going to go. Okay. So let's start with y2. Okay. What did we label as y2? 1. What did we label as y1? 4. Okay, what did we label as x2? 3. What did we label as x1? 0. Okay, so now we plugged everything in. Now we do our arithmetic. What's 1 take away 4? Someone else.
4.
Yep, 1 take away 4.
Which number is bigger, guys? 1 or 4?
4.
All right? What kind of a number is 4 in terms of positive or negative? Huh? Remember, sign to the left goes with it. 4 is negative, right?
Oh, I wasn't looking.
So your answer is going to be what? Positive or negative? Negative. Always take the sign of a larger number. Negative what? 3, good.
And then 3 take away 0? 3. Okay, now go through those ifs. Okay. Is the number on top bigger?
No.
No. Okay. Can that be reduced? Negative 3 divided by 3?
Yeah.
What does that reduce to? Negative, sure, you can write it as negative 1 over 1. If you want to leave it as a fraction, you could. If you wrote negative 1, we'd also accept that. That's
Now,
fine.
like Mr. Hager, like Kayla just said, negative 1 over 1, you can leave it like that. It's actually good to leave it like that because tomorrow, when you have a slope of negative 1, or any whole number as a slope, you need to know that it goes over 1. You can't just leave it as negative 1. You need to know it goes over 1.
Okay, so let's try one more, and then we're going to finish up with our 2 special cases where you didn't finish filling in the front of your notes yet.
So guys, let Mr. Hager and I walk around, take 20 seconds, and just, all we want you to do right now is just label them. And have us double check. Take 20 seconds, Mr. Hager and I are going to walk up and down the rows, label them, let us see.
Label them x1, y1, your x2, and your y2.
Again, we can solve.
Just like we did up here.
If you feel confident enough, go on to the next step and set it up.
All right. Somebody tell me, what's the negative 3? Ben, please turn around. What's the negative 3? x1. Okay, guys, we're back together now. Please focus. x1. Elijah, what's the 5?
5 is y1.
y1. Good. How about the 2? Yep, go ahead, Ryan. x2. What about the 8? y2. Okay. Now we fill in our formula. Okay. Somebody tell me, what's the first number on top? You can either tell me the letter and then we'll look it up, or just tell me what the number is. Go ahead, Elijah.
Wait, we're doing on top?
Yep.
I put 8,
Good. y2 minus,
5.
what's y1? Good. What's the first number on the bottom? Yep, Laura. x2 minus negative 3. Okay, start with 8, take away 5. What's 8 take away 5? 3? What's 2 minus negative 3? Yeah, why is it 5? What happens there?
There's 2 negatives.
Right. Now go through. Can we reduce this fraction?
Yeah.
No.
No.
No?
No.
Do we have a negative and a negative in the top and bottom? No? Okay, so we're done. Okay? So let's move on to our last 2 special cases. Okay? This time, the diagram, guys, stop talking. Okay, this time the diagram, they've already drawn the points for us. So we're not going to need the formula. We're just going to count. Rise, and then we're going to count run. Okay? So, what's our formula again? What goes on top? Rise. What goes on the bottom? Run. Okay? Let's count. What's the rise between these 2 points? 0. Okay? There's no rise. Everybody see why there's no rise?
Yes.
Because they're horizontal. How about the run? Is there a run?
Yes.
Yeah, how many?
5.
1, 2, 3, 4, 5. So what happens when you take 0 and divide by 5?
0.
You get 0. Okay, so this tells us something. When you have a horizontal line, notice it's not slanting upward. It's not slanting downward. The slope is 0. It's perfectly flat. Okay, so a horizontal line has a slope of 0. So if you didn't fill that in on your front of your notes, that's where you'd want to put this.
What? Where are we putting this?
You can put it right on the front of your notes. Okay, now let's look at our last special case. One more time, what's the slope again? What goes in the top? Yep. What goes in the bottom? Now, how come I'm not using the y2, y1, x2, x1? Why am I not using that here? Why?
Wait, what was the question there?
Why am I not using the y2, y1, x2, x1?
Because there's no point needed for it.
You don't need it. You've got a picture. If you've got a picture, you can just count. You don't need to do the formula. Okay? You only need the formula
With the graph.
when it's like that. Okay? What's my rise here? Elijah, what's my rise?
The rise, -2.
So from between those 2 points, how much do I go up? 1, 2, 3, 4.
I thought you were asking like what?
Now, what about my run? 0. Does everybody see why the run is 0?
Because it's just the same thing.
Yeah, you don't go left or right to get from one point to the other.
So it's undefined.
Yeah, so this is a little bit different. Okay, this time we got 0 in the bottom. Okay, what happens when you try to divide by 0? It's undefined. You can't do that. Okay, so what does this tell us about the slope of a vertical line? It's not that there's no slope. It's that the slope is, it's undefined. Okay, the slope of a vertical line is undefined. Okay, guys, I need your attention up here, guys. I'm not done yet. Okay, so the slope of a vertical line, that's undefined. Okay, so here's the 2 last cases we just did. Slope of a horizontal line is 0. Slope of a vertical line is undefined. Any other slope, it's either a positive or a negative number, and you use your formula to find it. Okay. If you forget, or you need to look anything up, okay, on page 416, it shows all 4 cases. Positive, negative, 0, undefined. Okay, any questions on those 4 types of slopes? It's pretty straightforward? All right.
We've only 10 more minutes.
So the homework tonight, it's going to be a worksheet that we pass out to you.
Wait.